We will continue EPA 608 Universal Certificate course. Now we are in type 2. We are in the module that its name is refrigerant recovery. We finished introduction and leak repair. Now we are finishing refrigerant recovery. Let's start with refrigerant recovery and let's study this module.
We described
In this module, we will discuss the different refrigerant recovery methods and a couple of techniques we can use for faster recovery.
We described refrigerant recovery as the process through which a technician removes refrigerant from a system and stores it in an external container. It is necessary to recover all or as much refrigerant as possible from the system during recovery. Refrigerant can be recovered in liquid or vapor form. Therefore, it is necessary to recover both the liquid and the vapor refrigerant in the system to ensure complete recovery. Let us discuss this in a bit more detail. Liquid refrigerant is recovered from the liquid line of the system. Usually, liquid refrigerant is recovered first as it is faster to recover. Since it's usually mixed with refrigerant oil, its recovery causes a loss of refrigerant oil. After the liquid refrigerant has been recovered, the refrigerant in vapor form is then recovered. Vapor recovery is done last because it can be very time-consuming. This is why it makes sense to start with the liquid refrigerant. Vapor refrigerant is retrieved from the vapor line of the system. Refrigerant vapor may still be mixed with small amounts of refrigerant oil. However, compared to liquid recovery, vapor recovery doesn't deplete the system's refrigerant oil as much.
Recovering refrigerant from a system in liquid phase will cause the loss of which of the following? In liquid phase will cause water, oil, refrigerant, non-condensable, okay, oil, yeah. After the refrigerant liquid has been recovered from the appliance, any remaining vapor is purged to atmosphere, isolated in the appliance, pumped into an appliance receiver, removed by recovery system. Okay.
Sometimes, leaks in the appliance cause air to leak inside during recovery, and a complete recovery cannot be made. In such cases, the refrigerant can only be recovered to atmospheric pressure. Remember, atmospheric pressure is the force exerted by air on the surface of the Earth due to gravity. Recovery time is the time it takes to recover a refrigerant. Generally, we want to recover refrigerant using the least possible amount of time. We mentioned that the factors that affect the time it takes to recover refrigerant include ambient temperature and hose length. We will now learn about two more techniques to speed up recovery: liquid recovery and recovery tank temperature. We've discussed how liquid recovery happens faster and, as such, reduces the recovery time. As we know, the pressure inside the liquid side is higher. This pressure is what helps push liquid refrigerant out of the system and into the recovery tank at a faster rate. By now, we know that the pressure and temperature of any substance are directly related to each other. Cooling the tank reduces the temperature and pressure inside it. Low pressure inside the recovery tank creates more space inside the tank and reduces the flow resistance for the incoming refrigerant. This leads to faster refrigerant recovery.
A technique to speed up the recovery process is use plastic recovery tank, cool the recovery cylinder, use 4-stage vacuum pump, heat the recovery cylinder. Yeah, to speed up the recovery, we need to cool.
In this module, we discussed the various refrigerant recovery methods used today. We also learned a couple of techniques used to implement faster refrigerant recovery.
Let's go to recovery equipment.
In this module, we will discuss the pieces of equipment used during the refrigerant recovery process. We will also talk about preliminary equipment checks that must occur before starting refrigerant recovery.
The main pieces of equipment necessary to perform refrigerant recovery from any system are recovery machine, recovery tank, digital weighing scale, and low-loss fittings and gauges. A recovery machine contains a compressor that helps to suck out the refrigerant during recovery. There are a few different types of recovery units, two of which we will be discussing here: hermetic recovery units and water-cooled recovery units. A hermetic compressor such as the one in hermetic recovery machines has all its components in a single shell. Due to its sealed design, its motor produces a lot of heat when working. Hermetic recovery machines depend on the flow of recovered refrigerant to cool down. When drawing a deep vacuum, the compressor motor overheats as there is little refrigerant flow to cool it down. This overheating is a common drawback of hermetic recovery units. A deep vacuum in a system is a state that is very close to zero pressure. Drawing a deep vacuum means that little to no refrigerant is left in the system after the recovery process.
When drawing deep vacuum, a hermetic recovery machine will run faster than other recovery unit. Okay. Overheat due to reduced flow of refrigerant through the compressor. Can use high compression of recovered refrigerant. Makes the oil used in hermetic compressor is become highly viscous. I'm not sure. No? Okay, when drawing deep vacuum, a hermetic recovery machine will run. When drawing deep vacuum, the hermetic compressor motor overheat as there is a little refrigerant flowing through it to cool it down. Ah,
A water-cooled recovery unit uses a condenser coil that cools down the recovered vapor refrigerant and converts it into a liquid. This recovery unit's condenser coil is similar to the condenser coil in a refrigeration appliance. Water from the local municipal water supply is continuously passed over the condenser coils to cool it. A water-cooled recovery unit is generally used to recover large amounts of refrigerant.
during refrigerant recovery, water from the local municipal water supply is used to cool the water-cooled chillers, hermetic recovery unit, water-cooled recovery unit, deionized water recovery unit. I'm not remember this one. Okay, during refrigerant recovery, water from local municipal water supply is used to cool hermetic recovery unit. No? Water-cooled recovery unit. Yeah, local municipal water is continuously passed over the condenser coils of water-cooled recovery unit during recovery.
Appliances that contain refrigerant tend to have recovery hoses and gauges for purposes like recovery, evacuation, and troubleshooting. All appliances and equipment manufactured after November 15, 1993, that are used for any such purposes must be equipped with low-loss fittings. Low-loss fittings prevent the venting of refrigerant fluid when connecting and disconnecting hoses to an appliance's service valves. Self-sealing connectors and hand valves are examples of low-loss fittings. Self-sealing connectors are easy to connect to the service valves. They can simply be screwed on or unscrewed off the cap without using force. Similarly, hand valves only require the turning of a valve.
Self-sealing connector and hand valves are used because they minimize the chance of an explosion, minimize refrigerant mixing with the refrigerant oil, minimize refrigerant release when hoses are connected and disconnected.
Note that it is not necessary to report the purchase of any recycling and recovery equipment to the EPA. Before starting the recovery process, there are preliminary procedures involving the evaluation of the recovery equipment that must be followed. Before transferring the refrigerant into an empty refrigerant cylinder, it is necessary to evacuate the cylinder first. This is because of the possibility that some air might have seeped into the empty cylinder. We consider air a non-condensable, so we want to avoid contaminating the refrigerant with it. All recovery machines have a filter at the inlet that filters out solid contaminants in the refrigerant, if any. After recovery, the filter tends to have trace amounts of refrigerant inside it. We know that the intentional mixing of two refrigerants is prohibited. It makes sense that the recovery machine's filter should be changed first. This is to avoid contaminating the new refrigerant with trace amounts of the old refrigerant.
What should be done before transferring a refrigerant to an empty cylinder? The refrigerant should be chilled, the refrigerant should be mixed, the cylinder should be heated, the cylinder should be evacuated. Okay. Yeah, I think the cylinder should be evacuated. Yeah.
In this module, we discuss the pieces of equipment used to facilitate the recovery of refrigerant. We also learned about some of the preliminary equipment checks that must be done before refrigerant recovery begins.
Okay. So we finished refrigerant recovery, refrigerant equipment. Let's go to recovery. Uh, recovery equipment. Let's go to recovery precautions.
In this module, we will discuss the different precautions to be taken during a recovery process. We will also talk about some of the standard techniques followed during recovery.
By now, each of us knows that venting refrigerants into the atmosphere is prohibited. Before starting recovery, a few precautionary steps are necessary to prevent venting. A technician should always check the service valve position before starting recovery. This is to verify that no valve has been left open by mistake. Refrigerant recovery machines also use oil for lubrication. The oil level must be checked before starting the recovery process. Low oil levels might damage the recovery machine due to insufficient lubrication, which can lead to venting.
What steps should be taken before using a recovery unit to remove a charge? Acid testing the refrigerant, purging the recovery unit with nitrogen, changing the oil in the recovery unit, checking the service valve's position and recovery oil level when applicable.
A parallel compressor system has multiple compressors in a single appliance. The compressors are connected in parallel so that they all have a single supply line and a single outlet line. A parallel compressor system is sometimes referred to as a parallel rack system. Such systems are commonly found in supermarkets and multiplexes. Because they all have a common outlet line, the pressure inside the outlet line will be equal to the pressure created by each compressor. When all the compressors supply refrigerant to a single outlet line, we refer to it as an open equalization connection. To recover refrigerant from these systems, it is necessary to isolate these parallel compressors. This is because, if we fail to isolate even a single compressor, it can resume the refrigeration cycle using another compressor's pressure.
Refrigerant can't be recovered without isolating a parallel compressor system because of the service valve connection, the electrical connection, an open equalization connection, thermal plate, an open equalization connection.
Earlier, we saw that recovered refrigerant may contain impurities like refrigerant oil, moisture, acids, and solid particles. Let's talk about why refrigerant oil is considered an impurity. We know that when refrigerant oil gets mixed with the refrigerant, it cannot be filtered out and reused. This makes any oil recovered from refrigerant an impurity to be discarded. In an earlier module, we learned how system-dependent recovery, also called passive recovery, requires the pressure of a functioning compressor to recover refrigerant. If we connect a non-pressurized refrigerant container to the system, the pressure of the container would be lower than the pressure inside the system. The refrigerant will naturally flow from high to low pressure, which helps along the recovery process. This is how system-dependent recovery works. System-dependent recovery is limited to appliances with 15 pounds of refrigerant or less. Using this method for appliances with more than 15 pounds of refrigerant is not feasible and is prohibited. Earlier, we defined a receiver tank as a storage vessel for refrigerant liquid coming from the condenser coils in an appliance. The receiver tank also plays a major role during the process of recovering refrigerant and servicing an appliance. When an appliance has a receiver tank, refrigerant can be recovered directly from the receiver tank's outlet. Note that this can only be done if the receiver tank outlet is at a lower height than the condenser coil outlet. If the receiver tank outlet is higher than the condenser outlet, the refrigerant is recovered from the condenser outlet. Refrigerant should always be recovered from the lower outlet. This strategy minimizes the risk of accidentally venting any refrigerant liquid left stuck in the system.
When should the refrigerant be removed from the condenser outlet? When should the refrigerant be removed from the condenser outlet? When the condenser is below the receiver, when condenser is on the roof, when the condenser is operative, when the condenser is above the receiver. Should be removed from the condenser outlet. If the condenser above the receiver, no, below the receiver. If it's below the receiver, we must remove from the condenser.
While servicing a unit with a receiver tank, there's another technique that can be used. Instead of recovering the refrigerant into a tank, the technician instead pumps down the refrigerant into the receiver tank to isolate it. The receiver tank acts as a temporary refrigerant cylinder that can store refrigerant during service. This saves us the time and effort it takes to recover the refrigerant then later recharge it.
When servicing an appliance with a receiver storage tank, the compressor discharge valve should be closed, the compressor suction valve should be closed, refrigerant should be pumped down to an isolated in the receiver, gauge pressure of 0 psia should be achieved when servicing an appliance with a receiver or storage tank. The compressor charge of valve should be closed. The compressor charge, yeah, I think this one is correct, I think. Okay. No? So the refrigerant should be pumped down to be isolated in the receiver, because I am using the receiver as storage.
In this module, we learn about the different precautions to be taken and a few of the techniques to be followed during a recovery process. These techniques and precautions are fundamental to preventing venting and protecting your equipment and the appliance from any damage.
Okay, let's go to the refrigerant recovery quiz. Let's attempt the quiz. We have 11 questions. Okay, when drawing deep vacuum, a hermetic recovery machine will. When drawing deep vacuum, hermetic recovery machine will run faster than other recovery unit, overheat due to reduced flow of refrigerant through the compressor. Yeah, it will overheat because drawing deep vacuum. A technique to speed up the recovery process is use plastic recovery, cool the recovery cylinder. Yeah, for the recovery, yeah, cooling. After after the refrigerant liquid has been recovered from the appliance, any remaining vapor is purged to atmosphere, isolated, pumped into appliance receiver, removed by recovery system. Yeah, I'm not sure from this one. During refrigerant recovery, water from the local municipal water supply is used to cool during the recovery, used to water cooled recovery unit to cool it. Recovering refrigerant from a system in liquid phase will use the loss which of the following: recovering refrigerant from system in the liquid phase. We will lose the refrigerant by this way. Refrigerant cannot be recovered without isolating parallel compressor system. Yeah, because of service valve connection, the electrical connection, and open equalization. Open equalization system, equalization connection. This will make problem. Self-sealing connector and hand valves are used because they self-sealing connector and hand valves are used because they minimize the chance of an explosion, minimize the refrigerant mixing in the refrigerant, minimize the refrigerant release when hoses are connected and disconnected. For self-sealing, minimize refrigerant release. What should be done before transferring refrigerant to an empty cylinder? Okay, the cylinder should be evacuated. Yeah. What steps should be taken before using a recovery unit to remove charge? Acid testing the refrigerant, preparing the recovery unit with nitrogen, changing the oil in the recovery unit, checking service valve position and recovery oil level, yeah, when applicable. When servicing an appliance with receiver or storage tank, the compressor discharge valve should be closed, the compressor suction valve should be closed, the refrigerant should be pump it down to an isolated, yeah, okay. If the appliance have receiver or a storage tank, I must pump it to the storage tank. When should refrigerant be removed from the condenser outlet? when the condenser is below the when should refrigerant be removed from the condenser? If it's below the receiver. If it's below the receiver, yeah. Let's check. Sorry. Okay, let's submit and finish. Let's submit. Okay, we had 9.9 from 10. It's been one question only is wrong. This one. Recovering refrigerant from system in liquid phase will cause the loss of the oil. The loss of the oil. Okay, this is the main idea. Let's continue also in this one. The next one, evacuation and charging. This system evacuation or dehydration. Okay, so we finished refrigerant recovery. Let's go to system, this evacuation and charging.
In this module, we will discuss the process of evacuating a system. We will also learn several tips and techniques we can use to perform a successful evacuation.
Evacuation is the process of removing all the air and water vapor in a refrigerant system. We evacuate systems before charging them with refrigerant to avoid contaminating the refrigerant with non-condensables. Evacuation is accomplished by sucking out all the air inside the appliance, leaving a vacuum. A vacuum is a space that is devoid of any matter, including air. The emptiest known vacuum can be found in outer space. It is called an absolute vacuum. When evacuating systems, it is our goal to try and create an absolute vacuum. It's not always possible to achieve an absolute vacuum, so instead, we aim for a deep vacuum. A deep vacuum is as close to an absolute vacuum as it gets. When we draw a deep vacuum, we leave very little air in the system. It is such a small amount that we need to measure the vacuum in units referred to as microns.
Which units are used to measure deep vacuum? PSID, PSIA, inch of HD, microns. For deep vacuums, I think microns.
Even though
Yeah.
we can draw a deep vacuum in any system, it is impossible to draw the vacuum to 0 microns as is the case in an absolute vacuum. We consider 500 microns to be an acceptable level for deep vacuum evacuation. At a deep vacuum of 500 microns, there is little to no moisture left as it has either evaporated or been purged out of the system. This is why evacuating to 500 microns is the standard set and accepted by the EPA and all manufacturers. That being said, different systems have different vacuuming or evacuation requirements. For instance, any high-pressure appliance containing less than 200 pounds of refrigerant should be evacuated to 0 inches of mercury, approximately 500 microns. Those with more than 200 pounds of refrigerant should be evacuated to 10 inches of mercury, approximately 250,000 microns. Any medium-pressure appliance or component with less than 200 pounds of refrigerant should be evacuated to 10 inches of mercury, approximately 250,000 microns. Medium-pressure appliances with more than 200 pounds of refrigerant should be evacuated to 15 inches of mercury, approximately 375,000 microns.
Technician has to make major repair in an appliance having 1000 pound of R407C. Which of the following levels must he evaluate to the system to? Okay, 0 PSI, G, 25 millimeter HD absolute, 10 inches of HD vacuum, 15 inches of HD vacuum. Which level he must evacuate? I think this is 15. No? Okay, so 25. Incorrect, since R407C is high pressure refrigerant and the system to be repaired has over 2000 IPS of refrigerant, it must be evacuated to 10
After
inches.
achieving the required vacuum on an appliance, a technician should wait for at least a few minutes. If the system holds the required vacuum level, it confirms that it is not leaking anymore. For this to work, the appliance has to hold the vacuum for a few minutes to confirm that there are no leaks present. If there are leaks, outside air will rush into the system, and the vacuum pressure will start to increase. Pay attention to the wording of the questions you'll find in the exam. The EPA exam may use the word evacuation instead of dehydration, or in some cases, instead of recovery. We define non-condensables as any gases within the refrigeration system that don't condense into liquid. Common examples of non-condensable gases include nitrogen and other atmospheric gases. We already know that the discharge line of a system contains liquid refrigerant. We can tell there are non-condensable gases in the discharge line if the pressure in the system is higher than usual. The reason for this increased discharge line pressure is because the non-condensables stay in vapor form. As vapors, they exert more pressure on the refrigerant liquid, in turn increasing its pressure in the discharge line of the appliance.
Adult pressure of the blank side can confirm that presence of non-condensable gas is in the system higher in the discharge. Yeah.
We learned earlier that the pressure and temperature within any system are directly related to each other. This means a reduction in pressure results in a drop in the temperature within the system. While evacuating a system, the pressure decreases, and in turn, the temperature also falls. There is a possibility that any moisture inside the system will get converted into ice at low enough temperatures. If ice forms, it will clog the refrigerant piping. This is why it must be avoided. The risk of ice forming is high if a system contains a large amount of water or moisture. Evacuating large amounts of water from a system may not always be possible on the first try. Any water that is left during evacuation may freeze and clog the pipes. Technicians can use a special technique to avoid freezing. It involves stopping the process of evacuation periodically and increasing the pressure inside the system by charging it with nitrogen gas. Nitrogen gas will help move the moisture along the pipes, ensuring it doesn't accumulate in one place. The gas, along with the moisture it collects, can later be evacuated from the system. Using this technique helps to prevent the freezing of moisture inside the system.
Which gas is used to counteract freezing while evacuating system with a large amount of moisture? Which gas is used? Okay, R14, R22, air, nitrogen. Yeah.
Using a large vacuum pump leads to a faster evacuation, but ice formation becomes a bigger problem. The pressure and temperature in the system reduce very quickly during rapid evacuation, which can cause the water in the system to freeze into ice just as quickly.
Water present in the system can freeze if large vacuum pump is used.
In this module, we learned many things about evacuating a system. We also discuss some tips and techniques you can rely on to perform a successful evacuation. Understanding these concepts will help us learn how to perfectly evacuate a refrigerant system.
Okay, let's go to the next module. We finish system evacuation or dehydration. We'll go to refrigerant charging.
In this module, we will discuss the correct methods of recharging an evacuated system with refrigerant.
The temperature at which vaporization, boiling, starts to occur at a given pressure is called the saturation temperature or boiling point. PT charts contain the relationship between the pressure and saturation temperature of any substance. It allows us to know the saturation temperature at a given pressure for any refrigerant, and vice versa. PT charts are simply pressure temperature charts. We will learn how to read these charts in the coming slides. Consider this PT chart for our 410A. The units for temperature are either degrees Fahrenheit or degrees Celsius, as we can see here. To find the pressure at a specific temperature, we look for the temperature in question, then look across that row for the corresponding pressure. In the chart, the highlighted value of 80 degrees Fahrenheit corresponds to 235 psig. For example, if an R410A appliance is at room temperature, 80 degrees Fahrenheit, the pressure of the refrigerant in the appliance will be 235 psig. In the chart for our 134A, the value closest to 0 degrees Celsius is 1.7 degrees Celsius. The pressure of our 134A at 1.7 degrees Celsius is 30.4 psig as is highlighted in the chart. We will discuss the use and importance of these PT values later on in the topic.
What is the approximate refrigerant of an R400 machine at 80 Fahrenheit when the machine is idle? Okay, we need to open the chart. Let's go here and open the chart. Okay, and we will check here for R410A, R410A, 408, 410A. Okay, just 1 minute. R14, R404, 409, 414, 16, 404. Okay, 411. Oh, it's not in the chart. Yeah, 4010 here. Yeah, it's not in the upper chart. It's down. 410. Which temperature? We have 80 to R410. We asking now for 80 temperature. Okay, so it will be for liquid pressure 104. For vapor pressure it will be 90. So when the machine is idle, he's asking when the machine is idle. When the machine is idle. Okay. So it will be 143. Am correct? Oh my gosh. 212? No. Appliance Fahrenheit. The pressure refrigerant the appliance will be 235. The closest answer option is 238. Oh, how it will be. 410, 80. Okay,
Any
check
refrigerant
this one
recovered
later.
from a system, provided it stays uncontaminated, can be charged back into the system after repair. Earlier, we talked about the 3 Rs: recover, recycle, and reclaim. Sometimes, it may be necessary to recycle the refrigerant first. Refrigerant should be recycled if it has too many impurities. Instant testing kits are available to help technicians assess the purity of the recovered refrigerant to see if it needs to be recycled. However, if the repairs are only minor, recycling the refrigerant may not be necessary.
The refrigerant has been recovered to replace the evaporator coil in an appliance. After the repair, the refrigerant can be filled back into the system, can be sold as it is, and another equipment owner must be reclaimed, must be restored, can be filled back in the system.
Liquid charging means refilling the system with liquid refrigerant. It is faster and saves time. Liquid charging can only be used on appliances that do not contain water in any of their parts or components. In other words, it's only ideal for air-cooled systems. Service valves allow us to access the refrigerant inside the system without opening it. They are also very handy when we need to add refrigerant to a system. Liquid charging is always done via the liquid line service valve. Vapor charging is done via the suction service valve.
How can we charge a system having 80 pounds of R07C and has both an air-cooled condenser and evaporator? Okay, vapor charge through the suction service line, vapor charge through the liquid line service valve, liquid charging through the suction service valve, liquid charge through the liquid line service. How we charge system having 80 pounds of R07 and have both an air-cooled condenser and evaporator. Okay, okay. So the system have both air-cooled condenser and evaporator. So we can charge as vapor. Okay, through section. I don't know. I don't know this. I don't know. I want him answer. We can use liquid charging in the system, so it's liquid that has an air-cooled condenser and evaporator coil. Since these systems don't have water, there is no risk of an ice formation during liquid charging. Liquid charging is always done via liquid line service valve. So liquid charge through liquid line service valve.
In systems that contain water in any part or component, it's advisable to initiate the charging process with vapor charging. Let us discuss the reasons why vapor charging is recommended. After evacuating a system, the pressure inside it decreases to about 500 microns if you do the job correctly. In the PT chart, the temperature that corresponds to this evacuation pressure is much lower than 0 degrees Celsius, which is the freezing point of water. If liquid refrigerant is filled into this evacuated system, it will immediately boil into vapor even if the temperature is below 0 degrees Celsius. Take for example R134A. With an evaporation temperature of 15 degrees Fahrenheit, minus 26 degrees Celsius, at 0 psi, it is still likely to boil at freezing point. We know that boiling liquid absorbs heat. As it boils, the liquid refrigerant will absorb heat from the water in the system, cooling the water into ice. It is difficult to melt this ice, and at times the evaporator or condenser coils may rupture or crack due to ice. This is dangerous and must be avoided.
What is the evaporation temperature of R134A at 0 psi? I don't know. I don't know. Oh, the evaporation temperature of R134 at 0 psi is
It is for this
minus
reason that we
15
initiate
Fahrenheit.
the charging process in water-cooled systems with vapor charging until the pressure inside increases. The pressure has to rise to a value that corresponds with a temperature of 0 degrees Celsius or more in the PT chart. The refrigerant R134A can boil at 0 degrees Celsius when the pressure is less than 30 psig. As such, an R134A system has to be charged with vapor refrigerant until the pressure rises to 30 psig. The same applies to the refrigerant R410A, which can boil at 0 degrees Celsius when the pressure is less than 110 psig.
The risk of water in the appliance freezing while charging an R410A appliance will remain until system achieves a pressure approximately. I don't know. I don't know. He will answer the correct answer. The refrigerant 410A can boil at 0 Celsius when the pressure is less than 110 psi. Once the pressure reaches 110, there is no risk in that the water in
In
the
this
appliance will
module, we
freeze.
learned the correct methods of charging a system with refrigerant. We also learned a few pressure temperature values that can be memorized and applied later in the field.
Okay, let's take the quiz. Now we have the quiz for evacuation and charging. A technician has to make a major repair in an appliance having 1000 pounds of R07C. Which of the following levels must be evacuated to the system to? Okay, let's open PT charge. Sorry, you can open in Leo tape. Okay, but I think this is 15-inch or something. I'm not sure of this one. A dot pressure on the dot blank side can confirm the presence of non-condensable gas in the system. If it's higher in the discharge, how can we charge an 80 pounds R40 system with an air-cooled component? Vapor charge through the suction service line, vapor charge through the liquid line service valve, liquid charge through the liquid line. Okay, a refrigerant has been recovered during the replacement of the evaporator coil in an appliance. After the repair, the refrigerant can be filled back in the system. Yeah, we fixed the evaporator so we can return it. The risk of water in the appliance freezing while charging a 410 appliance will remain until the system achieves a pressure of approximately 410. Okay, let's check this 410 here in the beginning, I think 409. Okay. Okay. 410. Yeah, this one. Okay. So the values, any difference? 048.6 or something to check. 48.6. It will be I'm not sure of this one. Water present in the system can freeze if large vacuum pump used. Yeah. What is the approximate refrigerant pressure of R410 machine at 80 Fahrenheit when the machine is idle? 410 at 80. Sorry, 400. Yeah, 410 if the machine is idle. Okay. I'm not sure of this one. I'm not sure. Let's select one. Let's see. What is the evaporation temperature of R134 at 0 psi? What is the evaporation temperature of R134 at 0 psi? Evaporation temperature 104. Sorry, 134. Let's go. This 134 at 0 psi. Okay. Minus 17.8. Minus 17.8. So the nearest is minus 15. Which gas is used to counteract freezing? Freezing while evacuating system with a large amount of moisture. Nitrogen. Which unit are used to measure deep vacuum? Microns. Let's check. We marked 3 questions. Let's submit. 7. Okay, this one. We marked this one. Okay. 407, and the system is to be repaired at 200. Must be evacuated at 10 micron inch. And this question also, and this question. So this is all from table. We did not answer. We will revise it again. Okay, but we done here today. We finished. We can make it again. We finished here refrigerant recovery. Okay, refrigerant recovery and recovery equipment recovery precautions. And after this, we finished evacuation and charging. And that's all for this two. The next one we will finish repairs and safety. By this way, we will finish this type 2.